Alrighty. All right, looks like we're live streaming. We're going to wait a few minutes or so to let more people into the room, make sure that we even out there before we start.
Sounds good.
What happened to your tater tot background?
The tater tot background. There is a story behind that. I was pressed one day at the .NET user group, and I was using Zoom, and I didn't have any backgrounds, but I had just been looking at a friend's post on Facebook about how their grandma made tater tot hot dish or something. And for whatever reason, I saved that into my pictures folder. That was the only photo I had in my pictures folder, so I stuck it up on my Zoom background.
Yeah,
It starts conversations for sure.
we've been doing that a lot in Teams lately too, since they released that feature publicly, being able to change the background.
I also saw a tweet where someone said to help build the teamwork, the camaraderie of the team, have everybody use the same background. Like they're all sitting in the forest or they're all sitting in a meeting room. I thought that one was pretty cool.
It'd be cool if it was like a panoramic shot, so everybody has different trees behind them.
Yeah.
Okay. A couple more people coming in. All right. Well, welcome to the 4 o'clock hour. We've got William Austin with the Flutter Clock contest fail. I've got at least one message here to give out. There have been a lot of questions today about the setup and how everything for the conference got put together, including a spa app, how they're scraping the video feeds and providing those right away, or within 30 minutes or so of them being broadcast. And so they're going to extend the closing talk today at 5, and they're going to go over some of that with a Q&A at the end. So stick around for that. So once again, welcome, William Austin with the Flutter Clock contest fail.
All right. Thank you, Michael. Thanks, everyone. This is a presentation called Flutter Clock Contest Fail. My name is William Austin, and you're at MDC 2020. A little bit about me. I am a technical architect right now as an independent contractor with Agile Thought in Tampa, Florida. I'm a previous MDC speaker from 2018. I'm the co-organizer of TwinCities.net user group. Don't you hate these brag slides? Let's just move through this. I've been in Tech Masters for 3 years, 1 year as the president. I'm active in the development and meetup communities, and my Twitter handle is wildbill00. This is me and my wife and our family and friends in front of the Allure of the Seas of Royal Caribbean. And the reason for this graphic is during this COVID quarantine, I've been doing a lot of cleaning of my closet, and I actually found the Surface Pen from my first Surface book. And I had seen a presentation by Jeremy Clark called Being a Social Developer, and he did all of his graphics by hand. And they were very clear, very succinct, and very non-distracting. And I thought, hey, I'm going to do that same thing. It turns out actually that Jeremy Clark's artistic abilities are much better than mine. But this is what we're going to have today for graphics. Now, wait a minute. You said you were the co-organizer of the .NET user group. You're a .NET guy. Why are you talking about Flutter? Why not? In our fields, I think it pays to not be a one-trick pony. I do know the Microsoft stack pretty well. I've done Xamarin. I've been a .NET developer for a very long time, but I really don't know the Google offerings. And I had seen an application called History of Everything about a year ago. And if you've worked with me in the last 1 or 2 years, you've probably seen me take out my phone and show you this app and say, look at this thing. It's fast, it loads fast. The animations are so smooth. And it's just a great app. And when I found out it was built on Flutter, I said, this is something, I have to look into this. So fast forward to the Flutter Clock contest. Flutter ran a contest and they asked people, design a clock. And the winner was to get a $10,000 MacBook Pro. But that isn't why I entered. I entered because I like these clock contests, or I like these contests in general. Typically, you get some type of starter code. The materials you're provided with are vetted. You know that things are going to work, that someone's proofread it, that there's not going to be errors. And three, sometimes you get to coordinate or you get to talk with other people in the contest who are in the same spot you are, and you can share lessons. Now, there's a video here of the actual winner from the clock. As the name of my presentation suggests, I did not win. I didn't even get entered. And there's a number of reasons why I didn't win, why I didn't get entered. Primarily, I chose to work on Flutter, which is brand new to me. Dart, which is the language Flutter is built on, brand new to me. And then I also threw in, let's learn MacBook while we're at it. This just didn't work out for me. So about 2 weeks from the end of the contest, it was clear I wasn't going to make it. What I decided to do instead was see if I could find somebody else's clock built in Flutter, kind of reverse engineer it and teach it to myself that way. And that's when I came across this article on Medium from Philip Okonkwo. His GitHub handle is npcomplete. And I read this article and I looked at his GitHub repo and I was really impressed. His code was very clear. His explanations on medium.com were very clear. And that's exactly what I did. I cloned his repo. I went through every single line of his clock, his Flutter clock, and I learned, what does this do? And there were times where I wrote down an explanation of something that I thought worked a certain way. And then 2 or 3 days later, I would learn, actually, that's not how it works. And so I would go back, redo that. So what I did is I took his repo and I added a comment to every single line in the app. And I plan to share that on GitHub after this presentation. But what is Flutter? Flutter is Google's UI toolkit. And up until about a month ago, it was Flutter's mobile UI toolkit. But you can see in my graphic that I've added a mobile device as well as web. So Flutter is now supported on web as well. Flutter provides fast development. And I think we'll see this much more once we get into the code demos, but it is really fast to develop with Flutter. They have an expressive, flexible UI. Everything built in Flutter is built with widgets, and they have widget support for material design on Android, as well as what they call Cupertino for iOS, so that your Flutter app running on iOS looks just like an iOS app. And lastly, they claim native performance. The performance is very good. From what I've seen, it is very close to native performance. What will we cover today? First of all, we're going to take a look at doing a demo of just the canonical Hello World with Flutter. Then we're going to get into an explanation of state. This is the simple out-of-the-box method for handling state in Flutter. There are more advanced techniques, but we won't get into those here. We'll look at the canvas. This is the graphics API for Flutter. And if you've done any graphics type programming, this should be pretty familiar to you. If you have not, I hope to teach you just enough so that you can understand the clock. And then lastly, we'll take a look at npcomplete's clock, and we'll break it down into its widgets. Excuse me. All right, with that, let's switch into our demo. This is VS Code, and all I've added is the Flutter extension, which also installs the Dart extension. So to kick things off, let's go to the command palette, type Flutter, new project. I'm sure I already have one called Hello World, so let's call it Hello World MDC 2020. And that's going to ask you, where do you want to put this? No, I do not want to update. Okay, it's done. Now, what I've noticed with VS Code is even though it says it's ready to go, we still have some problems here. If we wait just a few seconds, these should clear themselves up. Almost there. Wait for it. There. All right, in Flutter, you need to select the main.dart file to get things started, and it's always within this lib folder. So let's do that. Select main.dart, go to debug. Let's kick this off. First time you kick off a Flutter application, it does take about a minute. But after that, you will be amazed how fast it goes. Almost there, come on. This is all normal, trust me. I wouldn't lie to you.
Looks like my machine when they have two different antiviruses on there.
Maybe if I stop watching, it'll go faster. There we go.
Nice.
APK is built, so any second now, it should run over into Mr. Emulator here. Okay, there it is. That's the Hello World. And it's a pretty simple application. I'll show you what it does. It has a widget here for the state of the current number of clicks on the button. It has a widget for the button, and then it has a widget here for the text. Actually, everything in this UI is a widget, but these are the ones we're concerned about right now. And if I click the floating action button widget, we'll see the state increase. 4, 5, 6. Pretty simple, right? But what if your boss comes to you and says, "Hey, William, you know what? We got bought out, and our company colors aren't blue anymore. They're purple. And it'd be really nice if you had a different title that represented an MDC. So let's try that. Okay, now before I save this file, I want everybody to look right about here. Now I'm going to save. And that was pretty fast. Granted, the initial compile was pretty about normal for mobile development, but that was a fast update. We got the purple app bar. We got the new text in the bar. But look at this. We also maintained our state. The state did not go back to 0. In fact, this app is still running. I can go up from 12. I can go to 20. And while I was learning Flutter and reverse engineering Philip's code, every once in a while I would do something stupid that would cause an exception. like this. How about this would normally ruin my day? Okay, there was our little hot reload. Now, the next time I push this floating action button, it's going to hit this and it's going to throw an exception. There it is. There's my exception. We get a stack trace. We get some debug information. But my debugger is still attached. My app is still up and running. What if I went back and said, oh, you know what? I didn't really want to do that. Let's take that back out. And look at that. The app is still running. It preserved its state, even though I threw an exception. These are the kind of things I saw in Flutter that really made it, it really got me interested in it because I haven't seen this before, and it helped me iterate very quickly on what, the things that I was learning. I haven't seen this in other frameworks, and this is pretty remarkable to me. So let's stop this app and let's take a look at the Flutter command line. There's a couple things that you need to know. Once you install Flutter, you do get some command line support. The first thing that you probably run into is Flutter Doctor. This is like a diagnostic program to tell you, hey, is my Flutter setup correct right now? And if you get all green check marks, it is. If you get any red check marks, Flutter app probably isn't going to work and you need to figure it out. But this will tell you if you have any problems. The other thing that you'll need to know is if you pull down a Flutter sample project, you will need to restore those packages in it, just like you would with Node using NPM or .NET Restore in .NET Core. You need to pull those packages down. This is the command to do it. Flutter pub get. Now we don't have any or very few packages, so it only takes 0.7 seconds. But those are two command lines that you'll need to know. If you go and pull someone's sample Flutter project, you're going to have to run this before you can run the actual app. All right, let's look at the file structure of the Hello World. So starting here at the bottom, I'm going to skip the ones that I don't know about or that I don't think we need to talk about. This one is a big one. Pubspec.yaml, that is basically your packages or your package.json file in .NET Core or Node or JavaScript. This says, what packages do I need? Pubspec.lock similarly tracks the versions for the packages, just like it would in NPM or NuGet. Let's skip those. There's a test folder where they've given you an out-of-the-box unit test. There's a lib folder, and we talked about this before. This is where all your user code goes. I found this a little strange. I kind of expected my user code to be out here, but it's actually in the lib folder. So remember that. And if you're in iOS, and you probably need to know where the info.plist file is, it's within iOS runner, and there it is right there, info.plist. No, thank you, VS Code. Similarly, if you're in Android, you want to know where Android manifest is. It's in app source main, and there's Android manifest. And the rest of these I'm going to skip over. I find that there's a lot of the guts of Flutter staring me in the face here, and I would almost prefer these to be hidden somewhere. I don't want this one exposed to me. However, this is VS Code, and it is showing me all the folders. Maybe other editors could hide these from them, just like Visual Studio does. Okay, that is everything for Hello World. Let's go back to the slides. All right, so in that Hello World demo, we saw Flutter Doctor. We saw how the Flutter CLI works. I actually used the VS Code palette, but it's hitting the same thing, the Flutter CLI. We saw how you can debug and run Flutter apps. There's really no build operation like there would be with Visual Studio. You just kind of debug and run it. I showed stateful hot reload. This is the killer feature, I think, of Flutter. We talked about the startup file, main.dart. We showed the location of the iOS and Android configuration files. Ephemeral state, this is what is explained on the Flutter website. They refer to as ephemeral state as like simple state, just state that's inside of your widget. You don't need to share it with other widgets. We showed how you can restore packages in Flutter, and we showed the build method where the magic happens. Actually, we didn't show the build method, but we'll do that soon. Okay, to maintain state in a Flutter app, this is one way to do it. This is the simplest way. This is the way Hello World works, and it's the one we're going to look at. There are other ways of storing state, similar to like a Redux. There's one called Block that's pretty interesting, but we're just going to stay with a simple one. Now, there's a lot of code on this page. It's Dart code. It kind of looks like JavaScript, but kind of not. So through the miracle of high-tech animation, I've tried to help us walk through this. The first thing you need to do when you want to use state is extend from stateful widget. Next, you override a method called create state, and you new up a my homepage state, a new class. Now there's three things going on in this line, and I want to go over them one by one. First of all is this arrow operator. I don't remember exactly what Dart calls this, maybe fat arrow, but there's really no significance other than they say, if you're going to use this operator, make sure it's only one line of code after it. If it's more than one line of code, just use the curly braces like you normally would. Second thing, you'll notice that there's an underscore in front of this class. Underscore in Dart for a class name signifies private access. So when you see underscore, think, oh, this is a class with private access. And the third thing is, this method is actually instantiating a new private my homepage state class, but notice there's no new keyword in here. In Dart, they've chosen to not use the new keyword. That took a little bit of getting used to, but now I kind of like it. It's much cleaner, it's much faster to read the code. All right, that's step 2. That's all within this one class. Step 3, we're going to create a new class called underscore my homepage state, and we're going to extend the generic type of state, passing in the type of our first class. You can kind of see now how these two things are kind of bound together. And fourth, someplace in this class, you need to modify your state. You need to change something. But you can't just do it by doing counter plus plus. You have to wrap it in this function named setState. If you've worked with React, this is probably looking pretty familiar. It's a very similar pattern. If not, that's how it works. Finally, if you call setState on a Flutter app, what Flutter does is they're notified or they're aware of that change. Flutter is aware of that change, and it will force your UI widget to call build and basically rebuild itself. We'll talk more about that as we get further into this. Okay, Flutter Canvas and custom painting. Since what we're going to look at is a clock with arms and tick marks and numerals around the dial, we can't build that with just text boxes and check boxes and progress indicators. We can't build it. We have to build it completely custom on our own. And the way we do that is through the Canvas API. So looking at my my abstract Mona Lisa Picasso graphic over here, if you envision this as the canvas, then the top left is what we call the origin. Similar to what you probably learned in grade school or high school in geometry. top left, 0, 0. This is an X and a Y coordinate. But in Flutter, in the canvas, positive Y values go down. This, I kept tripping over this over and over and over. In grade school, in high school, I learned positive Y values on a Cartesian coordinate go up. Not here, they go down. We can do a thing called translation, where we can move this origin. And the reason we would do that is for things like rotation. So again, going back to this graphic, let's assume, or let's pretend that this is a picture on the wall, and this origin is a nail. If I let go of this picture, it's going to do this kind of a rotation. It's going to rotate around wherever the origin is. But if I drive a nail straight into the middle of this picture, and then I rotate the picture, I get a completely different rotation. It's still around the origin, but the origin has been moved. That's how a lot of the clock operations work that we're going to see later. The origin gets moved, gets moved to the middle of the clock. And you can also do a save and restore on the canvas. This tripped me up when I first saw it. I couldn't find documentation on it. It just didn't make sense to me. But eventually I figured it out. And what they're doing is they're treating the canvas and all of these operations you can do on it like a stack. So you could move the origin to the middle. You could rotate the canvas 90 degrees. And then if you save before that, when you call restore, it kind of pops off or erases all those changes you did to the canvas and brings it back to the last place you saved it. Pretty nice feature, pretty neat way of handling things. We'll see this later and I'll call it out then. Canvas also has a paint object. We're not going to talk too much about this, but it's very similar. This is my paintbrush. It's very similar to a paintbrush. You can set things like color and thickness on the paint object. And lastly, we're going to look at the path. Paths for our clock have two operations or two methods that we'll call move to and line to. And similar to how this little character has gone to the corner, then turned left, and then gone to this side, move to would move him, but not, or her, but not leave any tracks behind. Line to would say, wherever my origin is, draw a line to wherever the coordinates specified. It's kind of hard to wrap your head around now. I guarantee when we get into the clock and we start messing around with hot reload, this will make much more sense. But I need to give you this kind of preparation before we get in there. Michael, are there any questions? I'm moving pretty quickly. Some of this stuff may be new to people.
I have not seen any yet, but feel free to use that send a question button at the bottom of the session page.
Yeah, if you have any questions, just hit that button at the bottom right and type them in, and we'll take them as we go. Okay, custom painting. So if you have a widget and you want to control all the graphics on it, I think in Xamarin Forms, this is called, I can't remember the name, but you can do the same thing in Xamarin Forms. I love Xamarin. It's a little more complicated to do in Xamarin. I was pretty impressed with how it works in Flutter. Again, I've made a high-tech animation here to kind of explain this. But custom paint widgets need a custom painter, and the custom painter tells what graphics are actually going to be painted. We'll see this. It'll make much more sense when we look at the code in a few minutes. But your custom painter really needs to override one method, paint. There's another one called must repaint or something like that. We're not going to go into it. Paint's the big one. So here's my animation again. We have 3 custom paint widgets. And inside of those, we pass in a custom painter. So this custom paint has an hour hand painter. We're actually going to look at the second hand painter, but all 3 of these function almost the same. I picked second hand painter because it obviously moves every second, where these move just a tiny little bit in a second. This one's much more interactive, I guess, for lack of a better word. All right, NP completes clock. These are the major widgets in NP completes clock. We're going to be primarily concerned with this one. And then on the clock hand side, we're going to look at the second hand. We're not going to look at the minute. We're not going to look at the hour because, like I said, they're very similar. And really, this is the interesting one. But that's the breakdown. We'll also look at how does a real application handle state change. And we're going to look at some real life canvas and custom painting. All right, let's go explore NP completes clock. I have another Visual Studio Code. Let's move this one out of the way. Bring this one over. I already resized these, so they should fit just perfect. Okay, first of all, I'm going to bring the app up so you can see how it looks. And then we'll talk a little bit about what it does before we start digging into it. So as I said before, we need to find the main.dart file before we start the debugger. And actually, recently, they made a change where you can select any Dart file now and start the debugger, and it will figure out how to launch it. But I struggled with this before. If you don't have a Dart file selected and you go to your debugger, this debug thing just wasn't available, and it took some scratching on my head to figure that out. So let's wait for this clock to come up. I'm going to close that file and get things arranged. Okay, there's NP completes clock. I think it's pretty nice job. He's got tick marks around the outside. He's got labels at each minute. He's got a solid hour hand and a minute hand, and then he's got a second hand going around the clock. Now, when you look at this, I want you to ask yourself, what is the state that's changing in this app? What's changing? And I'm going to give you a second or two to think about that. Okay, if you said, well, the second hand is what's changing. That's moving every second. I can see it. That's close, but that's not the way that you think about Flutter apps or reactive apps. What's actually changing is time. Every 1 second, the change is to time. And that change is what's driving this UI to redraw itself. That's kind of a subtle change from the way we usually design software. So I'm going to say it again. What's changing is time. As the time changes in the state of this app, it's forcing the UI to redraw. Think of it that way. Okay, first thing we're going to do is we're going to take a look at main.dart. This is the first widget, and right here would be the bootstrap. This is what kicks off the whole app. Next, we'll go into what it's calling new my app. Actually, there's a new operator there. We don't need that, but it's there. My app goes to build, and we said that build is what actually starts building the UI. This build method creates a new widget called app clock. So let's look at that one. App clock has a build method, and it creates a widget called clock. So let's look at clock. And I know I'm moving kind of fast here. It's because I want to get through the things that I think are a little easier and spend a little more time on the things that are a little more complex, especially around the graphics API. So now this one should look a little bit familiar based on our state slide and my high-tech animations. We've got clock extends stateful widget, and we've got this private clock extends the generic type state, passing in the type from the previous class. That should look familiar. So let's go down into, what class is this again? This is clock. Here's our create state. Again, if you worked in React, this should look pretty familiar. This is where we new up the private clock class, which is right down here. That's all we're really concerned about in this class. Let's go down to private clock. And private clock right here changes the state, which is a date time. This is that like number 4, step number 4 in my previous slides. This is what triggers Flutter to say, whoa, you changed something in the state. I'm displaying UI based on that state. So my UI is now stale. I need to re-render it. And what kicks off that change is this line up here. Actually, this method, timer.periodic. What this does is it takes in an update duration, which for our uses is 1 second. Every 1 second, it will call whatever method is passed in here, which is set time. So every second, it comes in here, calls set time, sets its state, date, and time to whatever the time is right now. That forces a call to build. Real consistent. We've been talking about this as we go through the presentation. If you change my state, it's going to force me to rebuild my UI, and that means it calls build. Inside build, a little indirection here, it calls a method called build clock circle, just directly underneath. And build clock circle creates a clock face widget. Now we're getting into the actual clock. Everything else was kind of preliminary setup. Now we're getting into how is this clock actually drawn graphics wise. So let's look at clock face. Michael, how am I doing on time?
4:36.
Okay.
About 10 minutes.
Okay, clock face is the widget that we're looking at now. And if we go down into its build method, we'll see 3 major widgets. The first one is a custom paint widget for the dial. That's the outside of this dial with the tick marks and the numerals around the outside. That's it. The second widget right here is kind of a subtle one. It's actually a little black circle underneath here to give the impression that all 3 of these arms are kind of on a pivot point. We're going to skip that one. And the third widget are the actual hands, the second hand, the minute hand, and the hour hand. Let's take a look at this clock dial painter. Derived from custom painter that we talked about earlier. So we're looking for a paint method, and there it is. All right, inside the paint method, the first thing it does is figures out what's the angle and radians for each one of these tick marks. And since there's 60 tick marks around the outside of the clock, it takes 2 pi, divides by 60, and gets the angle and radians for each tick mark. Secondly, it says, well, what's the radius? And since we're inside of a canvas, it just takes half of that width to figure out what the radius is. Canvas.save, that means the app is going to say, whatever state the canvas is in right now, I want you to save that somewhere, like on a stack. And then canvas.translate, we talked about this earlier. What it's going to do is move that origin from the top left down into the center of the canvas. Then it's going to loop through 60 times, and it's going to figure out some stuff for, am I on an hour marker? If I am, you'll notice that these tick marks are a little bit longer and a little bit thicker than the minute ones. You know, this was a part where I struggled a little bit because there's so much going on. Let me show you through the benefits of hot reload, something like this. Let's say if I'm through my 4th iteration, I don't want to draw any more tick marks. And you can see now I've only got 4 tick marks. App's still running just fine. It's just we didn't draw the rest of the clock face or the clock dial. This kind of stuff, being able to make changes and immediately see the results is phenomenal. I mean, it really helped me figure things out, and I would love to work with this technology. So let's keep going. It goes down here and it does some simple math. This is a modulus operator. If I'm on one of those hours, let's put it back. If I'm on one of those hour tick marks, then I do need to do some special stuff. I'm going to skip this, but here's something interesting. If all of this is if I'm on an hour tick mark, 12 or 1 or 2 or 3, 4 around the outside. If I am, then I have to put one of these numbers down, right? But remember, we also just saw some rotation here in the canvas. It's actually down here where it rotates after it goes through each loop. Well, let's say right here at this line, I don't allow it to do this negative rotation. What would be the effect on the clock? Now when we look at the numbers, we get down to 6. 6 is upside down because as we've gone around the clock dial, we've continued to rotate. We don't want that. So that's why this line is in here to kind of unrotate the canvas when we drop those numbers on it. So it goes through all of those, rotates through each, rotates that radians degree or that radian amount each time through the loop. And then at the end, it calls restore. That's how the clock face is drawn. And we can do some fun stuff here if we wanted to. But let's go back into the second hand because that's the one that's really interesting. So I'm going to go back in VS Code.
Okay, you are on the 40-minute mark.
Okay. When do I shut down?
50 at the latest if there are no questions.
Okay, let's go 5 more minutes and no questions have come up?
No, no questions yet.
Okay, let's go into clock hands here and that'll pretty much round out the presentation. Okay, clock hands. This is the widget that does the hour, the minute, and the second. We're only going to look at the second hand because I think it's the most interesting one, and all three are really very similar. So again, we have a build method, and we have 3 widgets in here. Each one is a custom paint widget with a custom painter. For the second hand, we're going to go to this one, second hand painter. And we'll go to the paint method. And we see some similar math operations. Find the radius. Translate the origin from the upper left into the center. Rotate the canvas determined by whatever seconds I'm on. So if you were at 15 seconds, it would rotate what, pi over 4? And then there's 2 of these paths. Remember, we talked about paths earlier in the presentation where the person was walking with the steps behind them. There's one for the actual arm, which is this. And there's also one for this little tiny circle in the middle, which is really just a visual thing. But if we take that out, let's take out this circle right in the middle of the clock. And it is second hand pivot. So let's take this one out. And through the miracle of hot stateful reload, you can see there's no longer a circle in the middle. And now it appears that the second hand is just kind of floating there magically. That's not right. Let's put it back. Okay. All right, so this is probably the most difficult part of the presentation. At least it was for me when it came up. Right here, second hand arm is where we're actually drawing this second hand. And all of these operations are done in a vertical kind of up and down manner, but it's the rotation of the canvas that allows this thing to move around the outside of the clock. That's subtle, but let's look at it. So let's assume we're at the very first loop into the clock. The second hand is straight up and down. We're at seconds 0. So it's going to say second hand, the path, second hand arm is going to say move to 0.0, that's a float or a double value, to negative radius. So remember, our origin is in the middle of the clock and our X value is 0. That means we don't go anywhere left or right on the X axis, but it's saying move negative the amount of the size of the radius, which is about 160, 170 pixels for this. Negative goes up. So it's going to move up here. And then the next line on line 37 is going to say, now draw me a line from there to, starting at the origin, 0, 0, no change in X, to what we come up with, 165 divided by 3, that's about, what, 30 something, 40 something? So that's going to be a positive value of y, that means it's going to come down here. So the second hand basically starts here and goes all the way down to about here. And if we wait for this to get straight up and down, we'll see that's exactly what it does. So just for fun, when I was trying to figure this out, I said, okay, well, if that's how that really works, I should be able to put a circle right on the end of this because I know the coordinate. It's right up here. It's 0 minus whatever the size of my radius is. That's what this line here does. And I thought that was pretty neat. There's a little tiny circle on the end of this second hand, and I thought it would be very difficult to get it out there, but you know, the way this is done, the algorithm that NP Complete came up with, it's pretty simple. You can put the dot there. I can put it out on the end. I think that's about it for the second hand. Any questions, Michael?
We do have one from John. It says, regarding Google's history of killing off its own products, do you see Flutter still being around in, let's say, 5 years?
Yeah, I think that's a valid question. I've been burnt on that as well. From what I've seen, Google is all in on Flutter. They've had conferences on it. They're doing weekly YouTube videos. They have people traveling around the country, you know, evangelizing it. When I was in Florida, I went to DevFest Florida, and I actually saw her Twitter handle is Bouncing Sheep, and she's like one of the evangelists for Flutter, and she actually helped me set up my MacBook. But you know, I think that's a valid concern. I don't think it's going away. I think they're going to run with this. It seems like really solid technology. It seems like they're putting a lot behind it. But it's a good question. You know, always be vigilant. Keep your eyes open, I think. Any other questions?
That's it for now. Do you have more to present?
That is about it. I'm going to go back to the slides and we'll finish it out. Okay, lastly, resources. Flutter's homepage is flutter.dev. There's, I mentioned this, there's these YouTube videos called Flutter Widget of the Week. They're under 5 minutes. They explain how these widgets work. They're fantastic. This is a big one. This just got announced a couple of weeks ago. The App Brewery, which I hadn't heard of, is offering a free course, and it's solid stuff. Go sign up. I think you have until July, and this is advertised right on the flutter.dev homepage. I also heard in the last week or two that CodePen supports Flutter. So you can go to CodePen, you don't need to install Flutter, you can start messing around with it right away. And that's it. This is my email address, and again, my Twitter handle if you want to tweet me. That's it.
Cool. Thank you, William. We're going to hold for at least one more minute. I got burnt on the last one. A couple questions came in right after we ended. So if you have questions, please send them in. And then after the closing talk or during that same session, they're going to kind of go over all of the different tech that they built around this Minnesota Dev Conference, you know, from taking the video as it's being broadcast and creating another file of that that they can later replay, integration with Slack for this Q&A session. Yeah, stick around. Also, there's a survey button at the bottom of the session list. Go ahead and click that and fill out a quick survey. Let us know how we did, not necessarily Bill, but just everything in general, I think. Or sorry, William. Yeah, so I don't see any other questions coming in yet. Appreciate your time, William. Thanks a lot.
All right. Thanks, everyone.